I know, wow, we're talking about lazy imports again, but actually we're going to be talking about lazy assignments today, a new idea that I will hopefully convince you is useful and show you how I've made it possible. But before we do that, we're going to talk about lazy imports just to give you a small refresher because it's going to be relevant later. I've made this small example here where I am lazily importing async IO. The idea here is that I want to defer the use of this until it's absolutely necessary. So if we need to display something like help from an argument parser, we can do that really quickly. And then when we actually run the program, it's going to lazily resolve this import and actually perform the functionality. And so you can see, like, if we do best of, I don't know, let's run it 20 times and Python 3t help. I'm going to wrap this and send this to dev null because we don't actually, well, actually, let's make sure that it actually does the right thing first. Okay, yeah. So send this to dev null. It's just to show that, like, when we've deferred the import, we're taking 34-ish milliseconds. When we actually run the program, we're taking 56 milliseconds. And this is basically the difference between importing async IO or not. Actually, I mean, it's a little bit more because it's actually running and starting an event loop, but trust that deferring this import makes a significant amount of difference here. I guess we could just import the module. Okay, fine, we'll do that. Make a better example, Anthony. So, I don't know, I put a semicolon there. So if we do this with non-deferred import, it takes 50 milliseconds. If we do it with the deferred import, it's taking 16 milliseconds. So you can see there's a pretty significant difference in the amount of time that it takes. And by deferring that import, we can give you a faster help message here. That's the basic idea between async behind lazy imports. Man, all over the place today. Now I want to introduce this second idea, which is I wanted to lazy import YAML, and pretty frequently when I use PyYAML, I am also wrapping the loads function by saying loads equals, well, we're going to need functools also. Functools.partial YAML.load loader equals YAML.csafe loader. Because by default, safe load uses the slow pure Python loader, and so I usually want to use the fast but also still safe loader implemented in C. Now, you'll notice here, if I lazy import YAML and we look at how long this takes to import this model, it's still 15 milliseconds. As soon as I've introduced this loads helper here, we've gone back to the slow case. We're now no longer lazily importing YAML because we have used the YAML symbol at the module scope. So this causes this lazy import to trigger immediately, and so we've lost the benefits of lazy. Now, in an ideal world, I would love to be able to just say lazy loads equals this and defer this global variable, this module variable, until it's needed. And it'd be really great if I could do this. That was my goal. I want to be able to enable this so that I can lazily compute things at the module scope. Obviously, this syntax doesn't work. This isn't a real thing. And so we're going to try and make this work. Let's actually just use loads to load something. I don't know, X, Y. Sure. And we're going to start with our baseline, and I'm going to show you how I enabled this to work with a little bit of trickery. And then I'm going to show you behind the scenes how the thing that I made works. So let's just run this, make sure that this does what we want. What? Segmentation fault. I guess PyYAML might be broken in Python 3.15. That seems not good. Let's just use the purelib safe loader for now. I mean, it doesn't quite match the example that I wanted, but sure. Okay. What? It seems not good. Okay, anyway, what was I saying before I got distracted? Oh, right. Okay, so let's show you the thing that I made to try and enable this like lazy module level assignment. And I kind of want the code to work exactly the same as if it were eager here, and I want to preserve this lazy import here. So I made this thing called lazy static. It's sort of named after the deprecated Rust crate that does the same idea, which is to allow you to lazily instantiate module level things. And it provides a single API. That single API is from lazy static import lazy. It's this lazy helper, and it is a decorator. And yes, we slightly have to change how this works. We don't get that nice little assignment syntax, but we don't have to change the rest of our program at all. And this causes this assignment, this function here, to be lazily evaluated when the symbol is accessed. In the same way that if we had accessed, YAML down here, this symbol would lazily cause this import to happen. And that's it. It works. Let me show you it working, and then I'll show you how it works, and I'll show you another example that comes from the README that sort of demonstrates this. I guess the other thing is we can do this import example to show that, yep, we're still, 15, 16 milliseconds, whereas if we had not lazily done this, we would be at 30 milliseconds. Or I actually haven't tried this, but I think if we do this as well, this will cause it to, it'll cause it to eagerly evaluate this here as well, in the same way that lazy imports works. So this is this is actually a lazy import in a trench coat. But just to show you that, this program still works even with that. You can see that it's still evaluating that symbol, and we already showed that it's deferring that assignment there. The other really cool thing here is I didn't really have to do anything special. There's no fancy MyPy plugin going on here. This should just work with the type checker, not just with MyPy, but with other type checkers as well. If we look at, oh, actually, you know what? This might not work with type checkers because I don't have PEP 451, but because of the way single file packages are packaged, it's going to complain. Yeah, I couldn't find it. But if we copy the file out of the virtual environment, I really wish there was a single file PEP 451. Oh, types PyYAML. Because this, right. I don't know, let's show the MyPy stuff with a different example, because the typing of this is complicated. Okay, so anyway, that's the basic idea. I'll show you the typing in a second. Let's use a simpler example that comes from the README to show the same thing. Lazy static. Yeah. So this is the example that comes from the README, which I think is kind of simpler than this example here. Let's get rid of this one. So in this one, we have a function that returns an int. It's just a very simple prints computing, so you can see when it does the computation. And you can see that you just access the variable as if it's a global variable. You don't have to call it. You don't have to do any functools.cache. None of that gets involved here. And so, again, if we run this with the help, you can see that it has deferred running that function until we actually access it here. And so that's when this happens here. And here we can use reveal type to show it. Since the typing is just int, it's simple. Computed once, and if we run MyPy on this, you can see that it works. Great. So that's the idea. You can defer expensive computation. This is useful for preserving lazy imports or avoiding like regex compilation at your module scope, which can slow down your imports. Any other bulky object that you might be building as a global, you can wrap it in this little lazy thing, and it just sort of works. You don't need to use any extra functools.cache. You don't need to make an extra function call to access them. You don't have the function call overhead to access them. It uses the same mechanisms as lazy imports. In fact, it is actually a lazy import, so I'll show you how it works in a sec. But that's it. That's lazy static. I'm really excited about this because I was hoping that this was possible, and I've done some clever things to make it work. So now I'm going to show you how it works behind the scenes. And it's actually pretty easy to debug and figure out what's going on. Lazy static itself is 50 lines of Python, and a lot of this, well, a good chunk of it is type annotations in whitespace. So let's look at how it works. So first we're going to look at the actual lazy decorator itself, and that kind of move ourselves up from there. This is a function which is generic. It takes in a callable that the annotations say that it takes a callable and returns a value of the type of the return value of that callable. This is just, you know, decorator part, and then this is the trick that tells the type checker what to do. Now what it does here is we're actually going to build a lazy import out of that function that it wrapped. And so we need to give that lazy import a unique module name. We do that by prefixing it with lazy static. That's what double inner name is here. Then that function's module and that function's name. So this just gives us a module name that we're going to use, and we're going to turn that lazy decorator into an actual module. Now, it's pretty difficult to construct the actual lazy import type. It does live in types, lazy import type, but you can't construct it at all. You can't even do the typical trick where things are not constructible, lazy import type, where you can usually like smuggle them through object.new, but you really can't build these. There's no good way to build them, or at least I couldn't find a good way to build them without using the C API, but that seems super cheating. So the easiest way to do this is to actually use exec. And so we're going to use exec to build a lazy import object. What we're doing here is we have the globals dictionary here. We've written the syntax for our lazy import here. And we're going to import this capital V. This will come back later, but this is where we're going to store the value of the evaluated function. We exec this. This gives us back our lazy import object. The nice part about this is all really easily debuggable. So if we put a breakpoint here and we run our example, you can see that this is evaluating. Oh yeah, this is a bug in the current version of 3.15. You can see that the lazy decorator is being evaluated at the t.py module scope. We have made this G dictionary here. Ignore the rest of this. This is all just the built-ins being spewed into it. But the important part is we've made this V object, which is a lazy import for lazy static 5 underscores main 5 underscores computed once dot V. And so this is kind of our module name that we created here. I hate this. I hate this so much. It's so stupid that I have to confirm that. I hate it. I made a different video about how much I hate it. Anyway. So now that we have that lazy object, this is what we're going to return from this function and later allow the Python runtime to resolve that when resolving global names. The next thing that we have to do is we have to actually make this module resolvable. And so what we've done is we've made a module finder. Now, I said there's no functools cache. I guess there is functools cache here, but I'm just using this as a insert this and then don't ever do it again. We're making a finder. So the import system in Python is completely pluggable through sys.metapath and pep451 finders and loaders. And I have made a custom finder for these lazy modules here. We're going to put that into sys.metapath. That's what this thing does here. And then we're going to assign a function. We're basically storing a reference to this function that we wrapped earlier such that we can call it when it actually needs to get imported. Finally, at the end, we return back that lazy import object. And let's take a look at this lazy static finder. That's where the air quotes smart bits of this are. It's pretty straightforward. It's really just have a mapping of functions. These are the ones that we captured from our decorator. It's both a metapath finder and a oh, I can't scroll it far enough. Dang it. And a loader. This is the thing that finds modules, and then this is the one that execs them. Usually they're two separate classes, but it's easy enough to combine them. This is the finder portion up here, and this is the loader portion down here. Now, all the finder does is says, like, if we know about this function, we're going to say, yep, we found it. Here's our module spec. Otherwise, we're going to say, nope, we didn't find it, and let the import system continue on to other finders and potentially resolve this import somewhere else. So that's how the finder part works. The loader part is two parts. This function looks really stupid, but you return none for the default behavior because we're not actually customizing module creation. All we're really doing is attaching the V attribute to this newly created module, and we're doing that using the function we captured. And that's it. Like, it's pretty simple. It's really just capturing functions and then deferring them to a module creation time. And yes, it does create a bunch of like placeholder modules to represent all of these lazily deferred functions, but who cares? I mean, it's just an empty module, like essentially empty module in sys.modules. And that's how it works. You can actually see if we put a breakpoint here. That's the other part that I really like about how this works, is it's all pure Python. It's all, you know, very easy to step through and debug. Globals computed once. You can see here that, oh, what are we not? Oh, I forgot to remove the, I forgot to remove this breakpoint. I was like, what? What? That's not where I thought we were. Globals computed once. You can see here that it's that lazy import object, just as we saw before. If we access computed once, it's going to convert that global into the actual value here and run that function. This is just how lazy imports works. It's the same functionality, or the same mechanism, and that's it. I'm really excited about this thing. I think when I'm able to use Python 3.15, I think I'm probably going to be using this a lot, because it makes lazy imports like a lot easier to use. It also helps defer a lot of really expensive stuff to you know, running later. Anyway, hopefully you found lazy static interesting. I'm really excited about this thing, and you know, install it, try it out, see how it works for you. Yeah. If you have additional things you'd like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.